Our next speaker is Michael Reinstaedtler. He's been the head of the manufacturing engineering in the fuel cell electric vehicle components and the connected H2 cycle at the BOSCH plant in Hamburg. Previously, Michael was the head of the development of the common rail BOSCH plant in the Czech Republic and the head of the lead plant development common rail injector and rail in the BOSCH plant in Hamburg. Michael is a senior expert and technical coordinator for the high horsepower fuel injection equipment in the BOSCH plant in Holland, the team leader for mission priorities and validation in BOSCH in Stuttgart, and a reliability engineer in BOSCH Stuttgart. Michael, you're very welcome back to us and a good partner in BOSCH for the GenCom project. Over to you. Thank you.
Yeah, Paul, thank you very much for that. And what I would like to show you today is how we are doing sector coupling here in the BOSCH Hamburg plant. But first, let's start with why. Why are we doing this? Why are we going to a sector coupling in a commercial plant in a manufacturing environment? And the answer for that is, it's a big one. Our world around us is changing. It's changing very quickly right now. And we will be 10 billion people on this planet quite soon in the year 2050. And these people will live in the big cities all around. Already today, 60% of our world population is living in big cities. And these people need energy. We all need mobility. We all need heat. We all need electricity. We all need industrial processes for our daily life. But what this is doing with our planet is devastating. Climate change is real. So we've seen the 20 warmest years in the last 30 years, ever since recording. And if we now look into the future, if we are not changing our society, if we're not changing our behavior, it will be even more devastating. And this is a simulation. What will happen if we will have a 4-degree scenario? What will happen if our environment will warm up 4 degrees if we are not managing to achieve the Paris Climate Agreement? And our coastal cities will be in big trouble. And perhaps not London, not the big countries who have technology, who have the financial resources, but the poorer regions of the world, they'll be in big trouble. And we have to do something, we can do something, we as society, we as persons, but also we as companies. And I think here I'm always proud to show this slide. We as BOSCH, we are carbon neutral since last year, in Germany even 1 year before. And we are working on that with many, many projects. And what I would like to show you today is what we are doing here in Hamburg plant. And what I would like to show you is what we did in the past to come to hydrogen. Why is hydrogen such important for a big manufacturing plant for auto components? And we started 10 years ago with our energy management because we learned in the financial crisis, our output of the factory dropped down due to the customer demands, but our energy consumption stayed very high. And so we learned we have to do something. This makes no sense. And we have many different important steps which we done since that point in time. One thing is we are producing our own green energy. Green energy by solar power. We will have this year 8.4 megawatt of electrical power here in the plant. That means 15% of our energy demand will come from our own green energy. But that's only one part of the coin. The other part is we are reducing heavily our energy consumption. So in the last 10 years, our energy demand dropped 40% per product which is leaving our company. So 40%, 40% in 10 years, but we are still manufacturing here. We are still making goods, we are selling goods, but you can do it if you do a sophisticated energy management. And we did hundreds or even thousands of projects for that. And what is our key to do this is we have transparency. We use digitalization and we are using it to get better here in our energy demand. Because only if you know where your energy is used, you can have an answer to reduce this energy demand. And we have now more than 13,000 data points here in the plant. We know more or less from every machine what we are having, how much energy is used. And we are connecting this with several data. For example, we know in the plant how many people are working in which part of our plant. And if there are fewer people, you don't need so much light, for example. You don't need so much ventilation. You don't need so much fresh air from the outside. So we have now digitalization helps us to have a transparency to work on that. And up to now, the last 10 years, we mainly were working on projects with a return of invest for 10 years. for 2 years, because we are here a producing plant. We have to make sure that our costs are not rising due to being greener. No, our costs are going down while we are getting greener. And up to now, we said the best electrical storage is no storage, because a storage is very expensive. A storage has a problem. How reliable is it? Is it always available when you need it? If the battery is full, you cannot charge it anymore. If it's empty, you cannot use its energy. And our plan, and what we are right now doing, and this is what I want to show you today, is how we are solving the issue of energy storing here in a plant with hydrogen. And what we are using here is we are using already existing infrastructure here in the plant. We have a heat treatment which uses gray energy since decades here. We have here our own solar field. We are making energy, and we have our BOSCH energy platform which controls our energy flow in the plant. And all of that we are connecting right now. We are using excess energy from us or from our partners here in the region, giving this to an electrolyzer, and out of this we are getting green hydrogen. And the green hydrogen is then used for our industrial processes, our heat treatment. And from a carbon point of view, we're reducing with that our carbon footprint, but this is not a business case with a positive return of invest. And even in the mid-range, this alone will not work. What we learned over the last couple of years is we have to combine, and we will combine many, many use cases here in the plant. For example, here in Germany, our electrical infrastructure is the more expensive, the higher the energy demand at a specific point of time is. That means if we are just going up 1 kilowatt more electrical power, only for 5 minutes per year, we are paying close to 100 euros. And therefore, we're doing a peak shaving here of our energy demand by either reducing the energy consumptions devices or by making their own energy. And how we are doing it here is with a stationary fuel cell. And the stationary fuel cell is used to get energy again out of our hydrogen. And the more and more of these fuel cells you're using, the better and better is getting your return of invest. But it's still, I would say, from a financial point of view, not the perfect way what you want to do. But if you're going one step further, if you're further compressing your hydrogen, use it for mobility, then you're getting in the mid-range a positive use case while reducing your carbon footprint. And this is what I want to show you here where we are today. So we have our photovoltaic, we have a storage here installed, we have industrial processes, and we have SOFC, a solid oxide fuel cell, a stationary fuel cell, which is a BOSCH prototype, I will show you. And we have our smart control, our BOSCH energy platform. And right now, at the moment, we are installing an electrolyzer, which is capable to produce 20 metric tons of hydrogen per year. We are installing now compression devices that we can use our infrastructure here in the plant for our own green hydrogen, and we can distribute it with a filling station for pressure devices. And we are going on, and this probably will happen even this year. We will go to mobility. We are going to mobility. We have a refueler here, which will be available. And then we will make a green mobility. We will provide it here to the plant logistic while having forklifts, while having milk runs. But we will also provide this to the people here in the plant. The people want to know what is the thing about hydrogen. And we are providing them with hydrogen cars to really see what it is, how it's driving. And this is one of the future components for mobility. And so our electrolyzer, what we are having is that's a commercial one. Here's just the look of it. It's a ship container which has a lot of components in it, which is quite interesting for us to learn about these components, to build up here as a plant competences, and also makes us a valuable partner here in the BOSCH world for new products, but also for the outside world. And the other device, what we are having here right now, is a prototype of a BOSCH stationary fuel cell. That's one of the most efficient gas-to-power units built even right now in the sample stage. We have an efficiency of more than 60%, and we have a thermal output of a 10 kilowatt device of something like 3 kilowatts thermal at a very high temperature level. That means we have here power. We have here heat to power, and we can use this in the plant, and we can scale this up. We have only 1 kilowatt device, but you can scale it up performing to your needs. And it's quite flexible. If you're using it with hydrogen, if you use it with green hydrogen, it's CO2 neutral. You can use it also biogas, but if you have not this available, then you can also use natural gas. And even with natural gas, the solid oxide fuel cell is more efficient than the German grid. And with this, at the moment, we are here in the sample stage, but we will start mass production with 200 megawatts per year in the starting point of BOSCH solid oxide fuel cells in 2024. And this is a new product for our plant. So we're not only using it, we are also producing it, and we are creating jobs with this. And this is why we are in all these new components. We want to have new components, we want to have new technologies, we want to be a partner here, and we want to provide this to the community. What we're using as a refueler station is the Y-refueler from Wistrach. And that's a quite interesting technology because it's very, very flexible. So in principle, you just need a 64 amps connection, and then you can use it everywhere in the world. And it's proven its reliability already on many locations in Europe. And we will integrate it at the beginning, I would say beginning of summer. We will integrate it here in our plant infrastructure, and then we will be capable to refuel very, very different applications. Like I said, forklift milk runs, and several applications we can use here in our plant environment. And perhaps you're asking yourself right now, what is it about the fuel cell and mobility? As there are many discussions ongoing, what is the future of mobility? And the answer from us is there will be many, many different ways of mobility, but the fuel cell is definitely on its way, and I want to show you why. The question is always how far you are driving and how much weight do you want to carry? And if you think about internal combustion engines, that's the same choice today. If you have lower driving range, if you have lower weights, then probably you will use a gasoline engine. But if you're going to a higher driving range, if you're going to the big segments, for example, the Class 8 trucks, then you're going more and more into the diesel engines. And the same is probably true for the future electrical mobility. We have the battery electrical vehicles, and we will have the fuel cell electrical vehicles. And the higher the driving range, the higher the load, the more it's interesting to go to the FCEVs, to the fuel cell electrical vehicles. And when we think about commercial vehicles, it has a very, very big advantage. The refueling goes very, very fast. We are talking about minutes and not about hours. And the second thing is the costs for hydrogen is coming down. The costs for renewable hydrogen are going down right now, and it will be a business case. The total cost of ownership for hydrogen trucks will go lower and lower and will be more and more competitive, what we are seeing right now. And for passenger cars, it's a user experience, as you can refuel your car within a few minutes, 3 minutes, and you have a driving range about 500 kilometers with that. And so for the fuel cell electrical vehicles, we have here 3 components in Hamburg plant, which I want to briefly show you today. And these components, we are right now in the industrialization phase, and we are right now preparing our start of production for worldwide delivery of these components. One of them is a node recirculation blower. That's a recirculation blower which recirculates surplus hydrogen back into the system to be more efficient, to reuse it. We have another component, which is a hydrogen gas injector, which is providing the hydrogen to the system to make sure that the fuel cell itself always has enough of fuel available. And what we are providing is the air for our fuel cell. We have an electrical air compressor here, which brings the required oxygen into the fuel cell. And with that, I will summarize. We are reaching here our targets as a company, and we are providing the blueprint also to society, how this is be done. We have many examples here, and we are not only doing this to get greener, we are also doing this to create more jobs in our company, and we will provide these to the outside world. Yeah, thank you very much. That's what I want to show you today.
Michael, many thanks for an excellent presentation. It shows the leadership that companies such as Bosch and the opportunity they see in hydrogen. And there's a few questions here for you, Michael. Just give me a couple of seconds. From another Michael O'Mahony asks, would batteries be more cost effective for energy storage than hydrogen as a first step, with hydrogen for longer duration storage?
Yeah. So we were investing in this heavily, but we've seen a return of invest periods for batteries, which is at least a double time if we compare it to a hydrogen cycle. So we have a lower return of invest. It takes longer that this is really a business opportunity. And the second thing is, we don't want to rely just on one battery or on a couple of batteries here in the plant, because as I said, if the battery is full, you cannot put in more energy. When it's empty, you cannot get it off anymore. And therefore, we actively decided against the battery here in the plant. In future, when prices are dropping more and more because the production is going up, this might be a good solution to buffer some time. But if you want really to store the energy from the autumn winds into the next summer, this will not work with batteries. Therefore, you need hydrogen. It's much, much easier to store hydrogen than electrical energy.
A question from Laima Clemas for you, Michael, is what are the costs now for green hydrogen? It's always mentioned in US dollars for a kilogram to be achieved. So what are your costs and where do you hope to go to with the BOSCH costs then, Michael?
Yeah, I mean, at the moment, if we see what we are paying for the industrial gas hydrogen, what we are using in our heat treatment processes, we will be cost efficient very, very soon because the costs are very high. If you are in a plant environment, you are buying, I would say, a couple of tons per year from Linde, from Air Liquide, all these companies who are providing you this, you are very close to 10 euros, which 1 kilo of hydrogen costs you. And this is something we can beat with this hydrogen cycle, even in a very short amount of time. We are talking about only a few years. If we look further into the future, if you see the studies where the cost of hydrogen will go, there are papers which are showing that we are coming into the range of less than 3 euros per kilogram. This is something which only works if you have enough excess energy and you cannot sell it in another way. But in future, the greener we want to be, the more excess energy we will have. And the more excess energy you have, the less expensive will be hydrogen.
And a final question for you, Michael, before you get your break, is from Kyle Flanagan. Should the physical location of hydrogen production facilities be supply-led, i.e. where the electricity is generated, such as the wind sites, or demand-led, where the electricity is consumed, like the industrial sites, on the basis that these two don't always sit side by side?
Yeah, that's a good question. And the answer is not very easy. My personal thinking is both will happen. If you have the big wind parks on the sea, probably you have a good chance to bringing big electrolyzers there. So it's a little bit like with the power plants. You have very big power plants and you can do the same. But there is still market, and it's for sure in the double-digit range, where you will produce locally your hydrogen and you can use it only locally. But this will help you to get rid of the transport issues. In future, if we are going to a hydrogen grid, we are all connected with pipelines via hydrogen, then it might again be a different question. But on the other hand side, if we have this grid everywhere available, it's even easier to produce locally. So I'm quite sure there will be a part of local production, but there will be centralized production too. And my feeling is the centralized production will be bigger, but it will not be in the more than 90%.
Michael, many thanks. Don't forget, folks, after each presenter, we have a short Q&A, but there'll be a larger Q&A at the end of the session where Michael will rejoin us. Thank you, Michael.
Thank you.